Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2017 Time Zone 2, stuff related to topic 19, the high level in terms of redox, especially the understanding of the standard electrode potential numbers, some calculations. Let's see, number 30. What is the standard half cell potential of copper? So you are going to find out this time only half cell potential of copper as given to you, but so what does they say? If the zero potential reference electrode is now changed from the standard hydrogen electrode to the standard zinc electrode, that means now we are going to switch from the standard hydrogen electrode to set reference as 0 now to zinc to set reference to be 0. So the idea is kind of interesting that it is actually not difficult, but just students may not be so quickly understand what are they asking for. What are they asking for is that for these numbers, supposedly we learn it all from the given data booklet, the standard hydrogen electrode series, right? But mind you, all these standard hydrogen electrode are only respect to a classic, we call it reference electrode. Reference are easily understood as something that we set 0. And based on that set 0, we just calculate or estimate the relative reactivity compares with the hydrogen electrode and see the tendency to do reduction or oxidation, and at the end we get a series of different strength of reducing agents and different strength of the oxidizing agents, right? So in short, these numbers are on top of a reference. The reference is using hydrogen electrode to Z0, right? Anything set reference going to be set 0. So that's why these numbers are on behalf of the setting 0 from hydrogen. So that's why we will be having this positive 0.34 for expressing the copper electrode because of hydrogen Z0. So if you understand what I'm saying repeatedly, that means now what we are doing is switching the 0 point from normally hydrogen now to zinc. That means the same series should be kept, but we just literally changing everyone in the series by addition or subtraction of a number, but the thinking mindset is we just switching the zinc electrode now to reference. So that means now we should be pointing out using the red pen, zinc U set 0. So if we want to put zinc to be 0, so given that under a difference reference using hydrogen, zinc is going to be negative 0.76. But if we want to make this 0, what we can do is we simply add 0.76. Then you can be 0. Make sense? So if I do so for zinc, I do so for everyone because the position is not changing. The series is still there to be fixed, but just the numbers is going to be changed because the reference point is different. So in terms of copper, if we use the reference to be hydrogen, it is going to be 0.34. But if we choose to switch the reference to zinc, everyone please plus 0.76. So if 0.34 plus 0.76, answer is going to be plus 1.1. So that means under the reference of zinc, every position will be adding 0.76 volt and to make a new numbers, but still with the same series. So that's why obviously the half cell potential of copper, if we now switch the reference point from hydrogen electrode to zinc electrode, then everyone will be plus 0.76 volt. And at the end, the answer will be 1.1 volt for this half cell potential. So that's why answer will be D.